This is Jenny Lee and Ariel's related rates calculus tutorial. Please take a moment to read this 1995 related rates problem. So the first step in solving this problem is to write out all the givens, and because this is a cone, you have the radius and the height, and the relationship between them will always be consistent. So you can write the ratio of the radius to the height is going to be 4 to 12, and thus the radius will be 1/3 of the height. So in this first part of the problem, they're looking to find the expression for the volume of water. So we're going to use the volume equation, where volume is 1/3 of pi r squared times height. And we previously found that the ratio of the radius to the height is the radius is 1/3 of the height. So we plugged that ratio into this problem and simplified. So for this next portion, we're looking for the rate in which the volume of water is changing in relation to time. And in the original equation, we're given just the volume of water. So we would need to take the derivative of the equation in respect to time. So using the previous equation, we took the derivative, so it'd be dv dt, the change in volume over time, and we plug in one of the givens, which is the height of the water is initially 3, and then you simplify and you get the volume of water is changing at -9 pi feet cubed per minute when the height is 3. So for the final portion, we move on from just the cone to also the cylindrical tank beneath it, and we're looking at the depth of water in the tank as the water from the cone is dripping into it. So we can use previous knowledge that the rate of water dripping will be what we found in the previous problem. So we know the volume of any cylinder is going to be pi r squared times height, and we're given that height is equal to y and base area is equal to 400 pi feet cubed. So we just use those two pieces of information to create the equation W is equal to 400 pi y. And then we need to find, because we're looking at a change in time, we again take the derivative in respect to time of both sides of the equation and isolate the variable we need, which is the change in height over time, dy dt, and we simplify to get 9/400 feet per minute.